vertexes and run fragment shaders on it. And that's not changing all that much. You just get lots more of everything. And I, again, think that most of the time, a lot of it will be spent on just making our lives easier so we can do a better job with the games. So some of the things like community backlash against the Xbox One, it was interesting to see the power of the public reaction on it. And there's a couple things that have played into the public consciousness on it. One of the things that was up early before even the major issues with the used games and always on and things like that was people being a little bit freaked out about Kinnect being on all the time. And my game system is going to be watching me at all times, and who knows what that can do. And I had a lot of conversations with people that really just didn't think that was right, that feels incorrect. I am completely confident that that's a very temporary sort of vision about things, where if we go back 10 years, the idea that everyone would be carrying around a phone that has your GPS located position at all times would cause a lot of the tinfoil hat crowd to go absolutely crazy. The idea that, yeah, but the government's going to have backdoors into all of these, they can turn them on and track everything where you're going. And, well, yeah, that's pretty much the situation, but, we just kind of carry on. The situation with Kinnect, there's already a ton of laptops where the webcam is kind of there, and you have issues with people remote hacking things and turning them on. And I wouldn't be surprised if there's not some absolutely terrifying hack that happens at some point that is a huge media issue with it. But we will just get used to it. A lot of these things are inevitable, like the people talking about Google Glass and the issues with people carrying around and having cameras recording things all the time. I think that's going to be a net positive for society, having this sort of ground truth that's retrievable in many cases in a lot of things. But it does have sort of social transition issues that we're going to have to feel through, as those are adopted. But there's a tide of technology that I think is, in many cases, stronger than what even regulations can hold back in a global world, where you can have sort of local places where you'll have stronger privacy regulations, stronger preventions of, like I guess in some European countries, you can't leave the devices on all the time, so Xbox certainly will not be required to operate in that mode. You can turn it off, but they have a vision for how it's going to interact with you, and we don't know yet. People have to try these things to find out if they're really going to be good. The thing that, of course, got Microsoft the most in the most hot water was the issues with always internet connected, being able to not having the used game transfers, that whole issue. And I do sort of fall onto the side of, I think the witch hunt was a little bit unjustified there. There are legitimate grievances that people can raise about how they would choose to have their game systems managed. I personally am extremely fond of having all of my digital purchases in a curated garden, all of my iTunes, all of my Amazon stuff, all of my Steam things. And it's a positive thing. I mean, yeah, you can have better and worse ways of doing that, but we are very quickly going to be past the age of having a game that you hold in your hands on optical media. I think that was another thing that was open for debate this generation was, were we going to have optical media at all, or was it going to be all digital distribution? It probably won't be many years before we wind up with SKUs that just have the optical drives deleted, and everybody will just be getting it through the net. I think that's, again, a clear case of the future is obvious right there, and it will be good for us in general. I go over this a lot with books, where I'm sort of a bibliophile where I love books. I have an Encyclopedia Britannica set that I hardly ever open, and all these things where we have a fondness for our physical, the fetishes of the objects that we've bought, but really it is just so much better having everything in the cloud and being able to get at it like that. The other platforms that I'd love to be able to develop on 3DS and some of the other things, other small platforms, I would like to see the games show up on the Vita or the Wii U, just to kind of play with some of the different characteristics that they've got there. But it's extremely unlikely to happen because there's a finite amount of time and there's only so many things that you can focus on. And there's the fact that you can't be you can't have complete knowledge of even one of these platforms. Even the handhelds now have so much going on them. If you know all of the intricacies of the ARM instruction set and their different extensions and the characteristics of the GPUs and the different memory mapped I/O registers there, even that's getting to be a little bit too big for somebody to to get a full grasp of. Or what happens is you're just finally getting the hang of everything 5 years into it when the console cycle changes again. And I can look right now with some fondness at the 360 and the PS3 and say, we've got a really good handle on this. We can do some great stuff in it, but it's time to put that aside and go on to the the next generation where we're still groping around figuring out what's going on. One of the other platforms that is, in my opinion, not going to be making a big impact right now is the sort of micro consoles where you look at the Oyas and the things that are just tiny little things that plug into your TV. In the long term, it's possible that things like that may become very, very important as they're coupled with cloud rendering and the distribution like that. I don't think that it's going to have a super big impact right now, but it is amazing to see how the relevance of Android has, the tidal wave of Android just pushing almost everything else out of its way. I'm still obviously an iOS user for most of my day-to-day stuff, but I did finally just in recent weeks spin back up a little bit on Android development, where I looked at it 3 years ago and I thought it was really pretty awful, but it's especially compared to Apple. But you look at paces of relative change, and Apple continues to make things better, but Google has made things better at a faster rate to the point where developing like a Java app on Android is really not that bad right now. You download the ADT bundle and you plug in your device, and it pretty much just works. In many ways, without the certification hassles of iOS, some things like that can actually be a lot easier. It's only when you get into the native development kit that things really fall apart in terms of not really looking well cooked at all. But when you look at the scope of Android and what they've done, it's the power of free. There's giving away the platform has been such a good thing for the entire sort of electronics industry, because if we look back 5 years ago, we had every little handset company trying to write their own operating system, essentially, and doing a very, very bad job at it. Now we still have the danger that everybody, they go take Google's code base and they mess it up in various ways while adding value. We've got that classic problem of, that's happened with video card drivers in the bad old days, and it certainly happens with the Android platforms now. But it's still worlds better than we would have been if they had to be rolling it by themselves. So that's been a great thing. It still has it has a lot of the messiness of Linux underneath it. That's still what's down there, and the development tools reflect it. But there's also some of the magic of it, where when I'm poking through something and I realize it's like, okay, this is going into the system library. Oh, I can just go get the whole source code for Android.jar and step in through that, and then I can look at the kernel drivers for at least the reference implementation of things. So that's pretty wonderful. It's not clear when I'll have an opportunity to do iOS development again to do a fair comparison, but taking things in 3-year gaps is great to see progress, where when you're just kind of sitting with it, you might not notice how much better things have been getting, but the Android stuff looks at least usable now. So we've got things like Nvidia Shield, which is basically a repackaged super smartphone in a high-quality handheld gaming format. And that's, it's pretty neat on there. It's got excellent ergonomics and good controls for it. It's not just a really crappy Bluetooth gamepad bolted onto a phone. But you can still see some of the warts of Android sort of showing through. Like I was playing Sonic on it, and Sonic is not supposed to drop frames. That's sort of the essence of what the Sonic the Hedgehog experience is about. And you do get an occasional stutter that I would lay the blame at Android. And you can go, when you ADB into an Android system and you do a PS and you look at pages of stuff scrolling by, like, what is all this crap and how is it helping make my experience better? It's a shame that that's not more nailed down now. Some of the problems may be not just scheduling, but also the drive for power management, where you'd think that if you have a quad-core mobile system that we could just be saying, well, let my game use 2 of those cores, put nothing else on there, and just let me be, like on a console, and have things where they schedule and you wake up in a fraction of a millisecond. But it just doesn't work out that way. You can have 4-millisecond difference in when you wind up waking up the next time. And I'm still new enough to all of this. I don't have the answers at the bottom of it, but the platform is not, it's not as much as you could hope for. And while it's all solvable, you can certainly look down and say, well, what do we need to do at the kernel level? What do we need to expose to make this better? Unfortunately, it probably won't get solved like that. It'll eventually be solved by just a complete surfeit of extra resources. Maybe when we have 16-core ARM processors, we can actually have 8 of them to ourselves, and and let all of the other stuff kind of use up the other processors. And that's sort of what the what Microsoft and Sony are doing on the big platforms, is reserving processors for the other stuff they want to do. And as a game developer, if we know, okay, we've got 5, 6, 7, whatever cores that are really ours, we can work with that. And we would rather work with that than having kind of random unknown things popping up and bothering us. Cloud gaming, again, I've been saying this for years. I think it will have a big impact. And while OnLive hasn't set the world on fire for anything, things are still progressing. It's, again, people will look at bandwidth or latency and think, it's not getting good enough, fast enough. But years go by, and things just get a whole lot better. We have a ton of bandwidth coming to a lot of houses now. And while it's not everywhere, just like you don't expect to be able to play your Xbox in the car, there will be places where cloud gaming is just not appropriate. In your backwoods cabin with the satellite internet link, it's not going to be a good idea. But there's going to be plenty of places where it's going to be practical, and it's going to offer really strong advantages for the consumer. Being able to kind of pop in and out of all of your games as fast as you switch web pages, being able to architect games for huge back-end clouds that can take care of resources where it never even has to go to flash. It's always swapping from somebody else's RAM in the cloud. Being able to have completely fair network play without any local prediction, being able to run them essentially as split screen with people in multiple places. So there's a lot of advantages there, and I think that there's I would bet that there will not be another console generation like this where we think about the Microsoft box, the Sony box, after this one. This one's going to last. This generation's going to last a long time, and I think it's likely that some combination of mobile devices, generic players, cloud streaming, and some other devices will wind up sort of fragmenting that around a lot of different front and back ends, rather than having the platform that's being developed on. But whether that's basically, you'll have to come back in probably 8 years from now to see whether that prediction comes true, because this console generation is going to have a lot of legs to it. So we've got all this power now that we've got on the PCs, when you can put in multiple Titans into a PC box and render just absolutely incredible amounts of flops and vertexes and texels. So what do we want to do with it? I think that the most important thing is trying to make the game development faster and easier, more iterations on creativity, because I do think that we are fundamentally creativity bound at this point. We can make the graphics a lot better. It's easy to imagine the limit case. So if you look at some fabulous Blur game trailer that's made to just make something look unbelievable, the state-of-the-art in offline rendered graphics, and they look pretty sweet. There's amazingly good stuff there. But a lot of what's amazing in game trailers is the director's view. It's the scripting and the layout of what's happening there. Something that I would love to see, and it would be expensive, and nobody's probably going to do this to satisfy idle curiosity, but I'd love to see somebody take just a random snippet of someone's game. Just, you're playing this game, let's just take 5 minutes somewhere midway through your game and give it the full offline rendered trailer treatment on there. And if you said, if we just applied unlimited graphics power, how much better would the game experience be? And I suspect not all that incredibly much. We can already do a credible job of rendering anyone's creative vision in the game. We still avoid some of the hard cases, some of the things that don't come out really well. We're not going to do a ton of furry creatures and deformable tribal worlds and things that are still kind of hard. But we can do a good job at anything that a creative director can say, this is going to be the greatest game ever, help me draw it on the screen. We can always make things a lot better. There's a lot of advances going on. There will be continuous improvements, but it's not going to be set the world on fire, that this is the game that you have to buy because the graphics are prettier. There are a lot of things that we should stop putting up with, though, things that we are sort of used to. It appalls me that we still have people that are targeting 30 hertz games for next generation. It's not that hard. It was hard to hit 60 on the current generation. There are scars in the code base and on the developers that that let us make it to the quality and performance level that we did. But we've got a lot more power now. And yes, you can throw it at doing some crazy pixel shader to get some final little bit of physically correct lighting onto the screen in the pixels, but it's going to be lost in the difference in non-calibrated color between people's TVs, and I think it would just be much better for people to concentrate on smoother game experiences. And I see this where you see somebody talking about a very advanced rendering technique, talking about subtle differences in the specular lobes of the BRDF of this material, and there's a demo going with a tear line flying up and down the screen, where this is just not, priorities are out of whack. And we do get tunnel vision on our own little thing. I mean, graphics programmers as a whole, and then rendering people in specific there. But stepping back and looking at the whole thing, we should have complete, consistent frames presented. We shouldn't have a tear jumping around. A problem with that is that it means that you are limited to these notchy frame rates. 30, 60, 120 in some cases. And it means that it's harder for subtle performance differences to show. I mean, benchmarking is all about, do you get 32 or 47 frames per second? And if you're playing the frame rate game properly, the locked frame rate, that's not a valid distinction between them. Maybe you start doing like we do with resolution scaling, but it takes away one of the bragging rights things. I mean, that's sort of always the fun of the PC gaming rig culture of just the hot rodding for the modern days. But it's not necessarily in the best interest of the full gaming experience, rather than just throwing more of a moving the dial a little further over. We see a lot with some of the graphics things that we still have DXT compressed textures that turn a lot of things into garbage, and it doesn't matter what you do with the fragment shader there, if garbage in, garbage out. But even if you step back a little bit more, where the normal maps that we use for everything are, everybody bakes 8-bit normals. And interestingly, even with the first GeForce that supported sort of normal mapping, Nvidia recognized that 8-bit normals really aren't good enough, and they had the 1616 high-low format to have, like, if you want to do a smooth compound curve like an auto body, you can't use an 8-bit normal map on it that's referenced in global space. It's just not good enough. So making some of these transitions where, okay, we've got a lot of memory, now we can just stop doing some of these things that we're so used to. Use some more uncompressed textures. Don't use certain formats. Getting to gamma correction for everything, and a lot of these things that will make subtle differences, but they're not gonna change the face of gaming. These are things that it'll make gaming better, but it's not going to be something on the level of some of the breakthroughs that we've seen in the last couple decades, as we got our first 3D experience, our first 6 degree of freedom experience, as we moved to GPUs in the first place and started taking some of those strides. I honestly don't think that there is another stride of that level really left. Eventually, we will get to fully physically based ray-traced rendering. It's not coming in this generation, but it's coming eventually, and it will win. In the long term, I think there's almost no argument against it. And it'll be great. It'll be better than what we've got, but won't change the world. Some of the things like that we still see funny in graphics engines when you're doing super sophisticated things. Animation, it looks at, looking at games, and you see something that's this gorgeously lit, local subsurface scattering and everything, and then you see a box on something just slide right through an arm, or all this interpenetration of things that are just blatantly and grossly unrealistic. You can say, oh, but my light transport is on the nose, but when the simulation of what's actually going on is completely off, you're it's not the full experience that you're expecting there. So a lot more work has to be done with that to go ahead and make simulation of things better, to make presentation of human and animation, all these different things to climb completely out of the uncanny valley in all conditions. There's tons and tons of work to do there. And I think that the things that will make the largest differences probably won't be in exactly the pixel rendering. I still love it. I'm going to talk a lot about it tomorrow on where those final things that we do need to do to get to really, really correct and right pixel rendering, the physics of it, what we can change, but it's not going to really radically change the scope of the gaming. So the GPUs that are giving us all this power, we probably will be able to use more and more of it for things that aren't graphics rendering, being able to use it for the simulations. And there's been, for a decade now, people have been talking about, well, we're going to be able to use this stuff to make better and better physics or better simulations of different things. And it's been troublesome because you can't make physics a fundamental aspect of the game and make it optional or scalable. It just doesn't work out that you could have a low-end system have slightly different physics solvers. So all we really get to use that for is fluff. You get your cloth waving in the breeze, your grass, and your water surfaces, and all that's great. We'll get a lot more power from it. So faster and faster GPUs are still a good thing, even if you believe that we're past the knee of the benefit curve for pixels. All this power will still get used for useful things. And there may be some tipping point where we cross a threshold and we really can do something that's important and magnificent that just wasn't possible before. I don't have a suggestion for that, but it's going to be the things that people don't expect, where at some level of power and simulation fidelity, we're able to do something really cool. So the GPUs, one of the trends that's going on now that the consoles are thankfully going to be leading the way on this is the unified memory. PC add-in graphics cards are very much swimming against the tide of history. Separate memory buses are the way things have been on graphics since the beginning. There's a lot of reasons why that's not a very great thing. Having to send things across the bus, having to manage separate memory spaces. We had to deal with that on the PS3 with the split memory architecture. And life is just much, much better when it's all unified. Intel is obviously bullish on this with their integrated parts, but there's a resistance from Nvidia. They have their stranglehold on the super high-end workstation class separate add-in cards, and they don't have as strong of a position with integrated parts, so they cater to their interest, but leveraging the unified memory space is going to be where a lot of the advances in development and interaction with the GPUs goes, where we should be treating the GPUs just like another processor. We talk with 4 or 8 or however many cores of CPUs. We work out our scheduling systems. Sometimes we do have our critical sections and our locks and the things we have to live with on there. Right now, with graphics, that's pretty much hidden behind an opaque graphics driver layer, where we need to get to the point where we can treat the drivers, we can treat the GPUs the way we treat the other CPU cores. And that's going to involve the vendors giving up some of their flexibility, and that's a hard fight, where right now, textures are still an opaque blob, and each vendor has their own way of organizing them. But forces are battling this, where we have, everybody has to support native formats, everybody has to be able to render to and texture from them for the Android platform, if nothing else, for the compositors, for running on whatever you're doing with Windows and the Mac. So we have to have this generality at least at that level. But I've been calling on them to document and expose all of their, the texture formats you want to use, the tiled and swizzled formats, because there's a lot that we can do to make things better. Right now, it's especially pathetic on Android. If you want to load a texture in on Android, you wind up loading it into Java, making a native buffer, passing that native buffer to the driver, which will copy it into some other place that maybe will be GPU related, and you've got at least 3 steps going through here. And what my vision for the future of a lot of asset management is, all of this should just be memory mapped in a 64-bit address space. It's all going to be backed by flash. We're not going to have this 15-millisecond rotational latency to deal with. But to be able to back something with a memory map file, we need to know exactly what the data looks like. So we need to know what these formats are. We need to know what limitations there are on tiling and alignment and so on. So this is one of my big pushes. I want to see this happen. I think it makes too much sense for people to really argue against, aside from strictly parochial concerns about your add-on card won't be able to do this as efficiently if it's going over PCIe, whatever. But it's a path that we will be evolving to that will make everything better, enable a lot tighter interactions. It'll be a good thing. So the virtualization of graphics resources finally sort of hit mainstream now with the tiled textures and tiled resources. And this is something that people that have been coming here have been hearing me bitch and moan about this for 12 years or something. It's finally in hardware that a lot of you own. It's still not what it should be because interactions with the operating system are hamstringing things. Where I come back to this, I really want this, please memory map this file. Please let me page things out. And some of this battle was convincing hardware people that the idea of any kind of a fault is ever a good thing. And you can use virtualization in a way like we do with the IDTech 5 megatexture in a completely non-virtualized way, and non-blocking way, where we let things go, fall back automatically, update as needed. But to be able to use it for something like geometry meshes, you really would like it to go ahead and say, I don't mind blocking for the 1.2 milliseconds or whatever it's going to take for this to come in from Flash. Hardware people still tend to run screaming at this concept that you're going to idle their cores for 1.2 milliseconds. But that's, again, one of those things that they just need to get over it. It's a net positive win for the entire system to be able to enable some of these things. To be able to have an entire application where all of your media resources are just set as completely static memory-mapped resources that you have pointers to. Yes, a smart app will go ahead and pre-touch, manage the paging of all of this, but so many loading and saving issues and issues with stability issues with games come from loading and managing and caching and dealing with all of this stuff. And making a whole class of stability things just vanish, that'll be wonderful. But it's still an uphill battle. And then once you've convinced them that, yeah, this is probably a good idea, then it falls back to, well, Microsoft won't play ball on this. Their OS, core OS, is very, very conservative, justifiably so, and there's value to that argument. But they're not. It's this extra level of difficulty. And Nvidia keeps telling me whenever I suggest something esoteric that I need to start using Linux as my development system, because they'll go hack the kernel for me right there and send something over. And it's been sorely tempting in many cases, because that ability to just have something just hacked right in, even if you know it's not production, but just to be able to answer a question, that's really great. I've got a couple things right now that I'm looking at that I really want these questions answered. We'll worry about if it can be how it should be productized once we learn whether it's actually a good thing to do. So another GPU thing that's interesting is the place for tiled renderers. And this is one that I may have gotten wrong many, many years ago, where I really disliked the PowerVR architecture way back in the day when you had the Voodoo cards and the things that were sort of friendly to develop for that just blasted right to a frame buffer, while the tiled renderers, they theoretically traded some complexity in the interface and the lack of sort of direct manipulation for a memory bandwidth efficiency, in theory. The problem with the PowerVR, there was a lot of issues with not having the proper blending modes, and there were driver issues, and the limits of the tiling architecture had some fundamental limits at that time, where if you went up beyond a certain amount, they just broke. Those are largely fixed now, and of course, Imagination Technologies with PowerVR went on to largely dominate the mobile space with the tiled renderers. And they're really darn good now. They're high-quality drivers. They're highly performant systems. You can get excellent performance out of them with good tools to back it up. And there was a conversation I remember having at a 3DFX technical advisory board where there was one of the other guys was basically saying it's a foregone conclusion that tiling architectures will win. And he was basing that on the fact that RenderMan is essentially a tiling architecture. And I'm not sure if that train of reasoning is exactly correct. Because memory has expanded, at least in pace with the limitations of, the scope of memory has expanded, even though the bandwidth hasn't. So these massive frame buffers, you don't have the same Pixar had to be tiled because of memory reasons, not because of performance reasons. And that's not necessarily true for us here. But they've done certainly a good enough job that, like I said at the beginning, it was credible that you could have imagined a next-gen console by Microsoft or Sony having scads and scads of tiled renderers. They scale really quite well in many cases. So I'm not sure where that's ending up. We do wind up with essentially untiled architectures for the current graphics system, so there's still life in them yet, and that's going to be interesting to sort of follow on. And I am taking way too long going through these. So I still think that the real action and the things that make a difference are in I/O devices. What we do on the screen makes a difference, but what you can do that's not a screen can make more of a difference, or what you can do to make it better. Displays are remarkably good nowadays.